Today, we're going to be talking about containerization, right? So what is even containerization and why did it even come to be? Why is it something that, was started? Why do we even talk about containerization? So early on, when we used to build applications, it used to be in a monolith architecture. When I say monolith, for some of us, I think who are into geography, or I think apart from geography, I can't think of what else would monolith come up, but monolith would mean something that is like a very large block of, let's say, large block of item or stone that is not really movable. So just something rigid. That's what monolith normally means, monolithic, right? And for monolithic architecture, it means that it's just something that is like a massive single item, right? I don't know how many of us use Lego blocks. Anybody? If you know about Lego. So I think we can just search Lego. Okay. So these are Lego pieces, right? So assuming, let's say this is my Lego block. You see all the pieces are together. And when I use this analogy in what do you call it, tech, or should I say in a website or something, it means that every function is together. So for example, now if I have an e-commerce app and I want to access my login function, my payments function, I want to browse products, add it to cart and all of that. It means that it all exists within one block. So now if I want to change or update any piece of this Lego block, assuming I want to remove the green, and let's say this green is our login feature, right? I want to remove this green colored blocks here. What will I do? I will have to disassemble the whole Lego block to actually change the color or update what I want to do with this green block here. And when you do that, what does it do? It actually creates a lot of problem, right? It can create like overhead risk and all of that for you. So that's why we said that monolith applications, they have a single large code base. Looking at this Lego block, that's how it is. Every single code is in one place. From the payments, the products, every single thing, you have it together. And then all components are tightly coupled as one unit. What does that mean? It just means that, as I said, all components are together. If you want to fix one, you have to remove something before you can change it, then you return it back, right? And it is also deployed as one single piece on a big server. So when I say on a big server, so traditionally, like monolithic applications, they used to deploy them on one server, and these servers will need a lot of memory and processing power, because imagine one server running an entire application. Of course, it has to have like large memory and all of that, right? And maybe the CPU cores and everything would be higher. And this meant that when you want to scale, I think last week Rashida would have spoken about scaling. When you want to scale, you have to duplicate the entire applications to more servers, which is actually a very, very terrible practice, right? And then we said that it causes slower updates and development and updates, right? So now, as I mentioned, if you want to change one part of the application, you have to test and redeploy the entire system. Imagine doing that every single time. When would you finish updating? How fast would you roll out your updates, right? It wouldn't work. So that's what monolithic applications mean. And because this didn't work, right, everything was together. It was very hard to work on monolithic architectures. It was slowing down businesses. Businesses were losing and all of that. They decided to move to something called the microservice architecture. So when we say microservice, what does it mean? So from the name, microservice, right? It means a set of smaller services in different parts. Looking at this image, you can see we have one user interface, but we have how many microservices? I think about 6. Each one has a separate database and separate thing it does. But everything was together. So, and Microservices instead is just that every service is responsible for one part of the application. So for example, let's say this is that our e-commerce app we spoke about. This is our login page. This is our login service. This is our payment service. This is our product service. This is the catalog service. Every single thing is separate, right? So if I want to update my login service now, that means I will only pick my login service here and go and work on it. Did I touch all of this? No, I didn't. And that means you can make your updates and scaling much, much faster. Can you guys see my screen?
Yes.
You can see it. Okay. From my end, it's showing something else.
Actually, the screen I'm seeing on my own end is applications change where we have the monolithic and the microservice architecture diagrams.
Okay, so I'm kind of using like two screens, and I think for some reason the what do you call it HDMI converter might be malfunctioning right now because it's shaking. I don't know why. What's going on? But yeah, so I might be taking breaks to kind of like fix that because it actually isn't. It's actually spoiling my flow a bit. Sorry. I'm trying to rearrange. Okay. So moving on, right? We said that microservice architecture, right, they are broken down into smaller and independent services, which we have already discussed. And if service is loosely coupled, you can deploy them independently. You don't need to deploy them as a whole, right? So you deploy them independently, but they will have to communicate over one network, right? And normally we use APIs to do that. So if one service fails, the other one will continue to run normally. And like this makes the whole, system more reliant and many service and all of that, right? So also it's deployed across many servers or containers. So each microservice can be deployed on a different server or container. And this allows you, as I mentioned, to scale. So for example, now if let's say our product catalog gets very heavy traffic, right? But our payment system, maybe people just keep coming to view the product and that's it. But then the payment system is not because people are not checking out. Let's say Tinubu has happened and people can't afford it, just came to check the price, but then there are lots of people coming to check the price. But then nobody is going to check out to pay. So if you want to scale, you only scale that catalog service. You don't need to scale the whole system. So as you're doing this, you see you're saving yourself cost, time, so much. That's why it's very important for microservice applications. So I think when you start working as a DevOps engineer in some companies and you have access to their repositories, you will notice that they have so many repositories, so many services, and everything is deployed separately, but they communicate with each other through like APIs, right? And as we mentioned, you can scale each service based on demand and then faster updates, right? When you're working on different services, when you have plenty services, you can have different teams for those services. Like now, Mary can be working on my login service. Folashade can be working on my catalog service. Goodness can be working on my, let's say, what else do people do? Maybe my cat service and all of that. So everything will be separate. And if one service fails, so now if the login service fails, will it affect the payment service? Can anybody answer that? If my
No.
login service should fail, will it affect my payment service?
No.
No, it wouldn't. Thank you. And why is that?
Because I don't think they're dependent on each other. They're like separate systems, so to say.
Separate services, not systems.
Yeah.
Separate services, exactly. So now that we understand what this means, I'll be moving on to the next slide. So because of this, there had to be a shift, right? to microservices. And because we're shifting to microservice, we're no more using monolithic type of architecture whereby you deploy on a server and all of that. We had to get a new way of deployment, right? So with microservices, like as we mentioned, each part of the application is now an independent service, but they can still communicate to each other, right? So we cannot use things like virtual machines. It is inefficient and resource heavy. Some of you, when we started this class, some of us set up some virtual machines like multipass, big grants, and all of that, right? So how has it been? If you go and check probably the space, the RAM, and everything that memory it's consuming on your system, it's quite very heavy. You have just, I don't know how many people have checked, but sometimes it's heavy. And if your system is not one that has higher specifications, like maybe you're using 8 GB RAM or 16 GB RAM with a lot of maybe a SSD disk also instead of a HDD, it might be slowing down your system. So when we have things like this, we know that we can't continue using virtual machines because it's resource heavy. So that's when we started talking about containerization. Containerization is the solution for deploying these microservices effectively or efficiently, I would say, right? And when we say containerization, there are many tools for containerization. We have things like Kubernetes. It's used for containerization orchestration. I think we'll speak about that later on. Docker is for containerization. LXC is for containerization, but Docker is the most popular and widely used tool for containerization. And today, that's what we're going to be focusing on. So now let's talk about containerization. What even is containerization that I'm talking about, right? And what is containerization is very simple. What does it mean? Just packaging your application along with its dependencies into a container. This container that we're talking about includes the app itself that you have built or has been built, the configuration files, the libraries, the runtime environment, but then it will share the host operating system's kernel. And this allows like for consistent and portable and isolated deployments of applications, right? So now when I say containerization, I'm just going to say it's the same way, just think of it as a container. If you look at Docker, Docker looks like a ship with containers on it, right? What do we put in these containers? Let's say our goods. But maybe those of us that have businesses, you went to China, you bought stuff, you put it inside the container. So think of everything you're putting inside the container as your app. When you're building an app, I don't know if how many of us here have built an app or have seen how the files that come with an app, but you would have your what do you call it, your application files itself. Some people will have requirements, some people will have some environment dependencies, like, oh, you will need to, I need maybe JavaScript, not JavaScript, I can say Flask version 1.200 for this application to run. So those are what we're talking about. You pack everything and put it inside a container. That's what containerization means. And why containers, right? Why do we even use containers? And it's because microservices by nature, they are small. They're very small and they're independent. So they need to be deployed frequently, right? And we've mentioned how we cannot use VMs, virtual machines, because they are slow and resource heavy. So Docker, which is a containerization tool, provides like very lightweight and fast starting resource efficient containers, and which allows my microservice architecture to fit into it. Earlier, we spoke about how VMs were the go-to option for hosting applications in the past, right? In a VM, it means you have to duplicate your entire operating system for each service. So imagine you have a login functionality, you duplicate your entire operating system. You have a payment functionality, you deploy the entire operating system. You're just wasting resources, and then it's very slow, right? And I think an analogy I can give for you to understand this is, imagine now you're attending, okay, you're hosting a dinner party for every guest, right? Let's say all of us on this call, Mary is hosting a dinner party for us. And then you have provided a fully, let's say, equipped house. And that your equipped house, in our analogy, should be the VM. You have provided the house. The house has a kitchen, bathroom, and bedroom, you know. And let's say, but all we need is to come and eat. That's what we have been in that your party. That's what we're doing in that your party. We just want to come and eat, right? So imagine all we need to do is eat in your house, but then you have a kitchen, you have a bathroom, you have a bedroom. It's already an overkill, right? So Docker containers are what is solving. They will only package the application and its dependencies. The containers will share the underlying operating system, but will still environment deploy. So now using our analogy, instead of giving each guest a house, because that's what a VM will do, for each service, it will give it a house. So imagine Mary's dinner party. I don't know how rich Mary is, but Mary gives me a house. Mary gives Falashade a house. Mary gives Salima a house, right? When all we need to do is to eat. We just need you to give us a table and seats to eat our food. So that's, let's say, that seat at the table that Mary is giving us is what a container is. So Mary can now serve all of us in one house. That's in a VM, right? One VM, but on a same table with plenty seats. So she can run plenty containers in the same house, which is the machine in our own analogy, right? So instead of Mary now to go and have plenty houses, Mary just has a house. She has a table that has several seats, and all of us can eat there. Is that not more cost effective? It is, right? Now, please, I hope we understand this, what I'm saying, just in case, before I move on. Okay. Only Safe is giving me a thumbs up. Okay.
I think everybody did.
Okay. Perfect. So, that's what it is about containerization and Docker and using VMs, right? So, you would see, I think I'm not really explaining from my slides. It's for you people to read later on, honestly. But yeah, so I think I'll give one last use case, right? So let's say a company that is running a content management system. Who can tell me what a content management system is? Or give me an example of a content management system.
Does Notion fit in here?
Sorry?
Notion.
Yeah, I would say it does. It does. So yeah, Notion will be part of it. Things like WordPress, things like HubSpot, things like, remember that blogger where you can, I think, create your websites and all of that. So basically what the content management system is like a software that allows you to store, manage, and publish web pages. And Notion, you can also do that on Notion. So who even said it, please? Who said it was Notion?
Elizabeth.
Okay, thank you very much for that, Elizabeth. Ha. So now let's say a company is running Notion, right? Let's say it's our CMS, and we use to deploy it with VMs. And to deploy with VMs, we need multiple servers, right? Because we need to handle traffic spikes. So for example, now this morning, and there are 1,000 people going to use our CMS, but last night it was just 100 people. So if last night we were using one server, can we still use one server when 1,000 people want to access our service? It wouldn't work. We'll just hear downtime. That's why you hear sometimes that, oh, WhatsApp is something is down or some apps are down, right? And as DevOps engineers, that is your work to make sure that doesn't happen. So we need to handle that traffic spike, right? But with Docker, you can now run each of the services. So let's say your front end is separate, your database is separate, you are caching in a separate container. And this will allow you to scale only the caching service when there's a traffic spike. Last week, you guys spoke about availability zones, I think auto scaling and some things in the cloud class, right? So this also applies here. When you cache your content, you only need to scale that caching service when there's a traffic spike instead of every single thing and having multiple servers and all of that to allow you to respond faster to the demand. Now, that is a use case for when you use Docker and all of that. Moving on, why Docker is perfect for microservices, right? So let's say that it is scalable, right? We have spoken about this multiple times now, and it's consistent across environments, right? So Docker ensures that your application runs the same way in development or testing or production. We all know that. I think we've not spoken about it, but there, I think I've forgotten what it's called. It's under product management or so. There are different types of environments in when you're building. You would have the development environment, which is for you guys to do your test and for devs to push their code, right? You have the testing probably, or they call it staging. Staging environment is mainly what has been passed from development. Features that are good will go to staging. Then what is in your staging environment should be up to par. And if it's good, it gets pushed to production. What development is where people used to do their rubbish. Staging is okay, you have to get your shit together. Production is okay, but we can't afford failure, so it has to be very good. So you can have your applications, they can run the same way. You don't have to worry about this, it works on my machine thing. I don't know how many, has anybody ever moved a code base from somebody else's system to their system and it worked or it didn't work? So there was a time when I was in university, I built this mobile application for somebody for her final year project. And it worked on my system, right? And I gave her this project. She went to defend it with her supervisor, and then it didn't work. And then she called me afterwards and was shouting, "Oh, I gave her something bad, blah 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 blah. It didn't work on her system." And it would not work. Why? Because there are different dependencies on all of our system. If I'm using a MacBook and she's using a Windows, do you think it will work? I am not saying that test environments are staging or all of that, right? What I'm saying that is that normally there are three environments people use. They use the dev, staging, and production. Test environment, you can have another environment for testing. It really has an environment called test anymore. All you do from the dev environment, you are already testing. If it passes in the dev, it moves to staging. Staging also we get another test before it moves to prod. Is that what you're asking for, Lashadi?
Yeah, I just wanted to
Because I'm
confirm
saying
that test and staging are not same.
you actually test in all the environments, even production you will test. So that's why people don't really have test environments as a separate thing. You start testing from dev to staging to prod. So staging is also a non-prod environment. Dev is a non-prod environment. So except if it's called prod, none of it is a prod environment. Okay, so moving on. So it would, I said that when the applications are moved from a system to another, it would not work because everything is different. So that is why on Docker, we actually bundle these applications inside a container. Anything it needs, whether the dependencies or the libraries, everything is in that container. So there's nothing like, oh, it worked on my machine, it's not working on your machine. Also, we mentioned faster deployments and updates. So Docker containers can start in seconds, and it's very portable, right? You can deploy them, you can update them, you can do anything you want. They can package your application very fast. So that is why continuous integration, continuous deployment pipelines, which is something you'll be doing with Salima tomorrow, they are often built around Docker. So now a developer, oh, I wish I had structured it for you guys, but a developer pushes code to the testing environment, to the dev environment, let's say. We build it using CI/CD. We build that Docker, we build the application and containerize it, right? Once we have containerized it, we push it, staging picks it up. Staging looks at it and say, okay, it's fine. I've tested everything is good. Let's move it to prod. This can happen in just barely minutes, and which is very fast, which is what we want, right? So now, let's say I'm trying to think of a use case we can use. Trying to think of okay. Let's say we have Uber or Bolt, whatever you use in your city, right? And on Uber, we have the driver service, right? With the drivers use. We have the passenger service for the passengers, and then we have the payment service. I think this I even ran up three main services for, let's say, a ride hailing service application or something. So now using Docker, we will containerize each of the services, the driver service, the passenger service, and the payment service. So once we containerize them, we can now deploy them and update them independently. So now let's say, as we said earlier, like maybe during peak hours, the passenger service will need more resources because people are requesting ride, right? We'll not scale that passenger container maybe from 1 to like 3 or 4. And payment service, maybe not much people are paying it, so we can just have like 1 or 2 containers until request for more is needed. Now, moving on, we're going to be talking about Docker components. So when we say Docker components, who can tell me, give me an idea? For those of us that have heard about Docker, it's fine if you don't know. What do you think Docker components will be or are? Anybody? Just guessing, because I think we might not know, but there are a few of us that have heard about Docker. Yes, please go ahead.
Docker file. Docker file.
Thank you very, very much. We can say a Docker file. That's nice. So that's one of the components. We have there are lots of components, right? I hope you guys can see the text written on this thing because I'm just realizing it's very tiny. Can you see it? Just give me a thumbs up if you can. If you can't, I think, okay, yeah, I guess so. If you can't, you can zoom in your screen, whatever device you're using. If it's a phone, you can pinch the screen I'm presenting to zoom it in. And if you're using a laptop, I think you can hover over the screen. You see like a zoom plus minus icon. You can click on it to zoom in. So please, can you see my screen now after zooming in? Can we? Thumbs up, thumbs down, any? Okay, good. Now, we're going to be talking about Docker images. So let's say a Docker image, right? When I say an image, it's just like a read-only template used to create Docker containers. Don't forget, guys, we did read, write, executable, and all of that, right? This is only read-only. And what is read-only? From the name, you can only read it. There's no need to complicate it. And we use it to create Docker containers. Don't forget, guys, we have containers and we have images. We've been explaining containers, but I'll also explain more here. Now, this image has everything needed to run an application. That image has the code itself, the library, the dependencies, the environment variables. Every single thing is in an image. Now, image consists of multiple layers. Each layer represents a set of instructions that we define in our Docker file, in this Docker file, but we'll talk about it later. So the set of instructions, it can tell you, okay, like install this, copy this file from this to that, you know, and all of that. And this is why Docker is very efficient because you can reuse these layers across multiple images. Now, when we talk about images, images are into two. We have base image and custom image. So there are templates that provide the foundation of your application. There are different types of images. Some images, this base image are images that have been pre-built. So now if I'm deploying a Python app, I can just go and look for a Python image to use. But if I have coconut head and I like stress, I can go and create my own custom image, right? And I can add my own application code or dependencies to my base image to create my custom one. And there are times where you have to create a custom image. Every time actually, what am I even saying? Because if you look at this Docker file now, can you guys see it? This Docker file, the instructions to build a Docker image. You'll see from Python 3.8 Slim. This is the base image. We are carrying an image from Python, and it is version 3.8, and they tagged it with Slim, which means it's lightweight. Anytime you see an image tag with Slim, it's lightweight. And all these instructions, blah, 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 copy app, run this command, we'll go through it later. If I run this file, I am making a custom image that is packaging my application. This image has now my application code, it has my dependencies, and it has everything there. That's what it does. So we actually do use a base image, and then we still use like a custom image. So like let me give you guys now a use case, right? So let's say that we are building a Node.js application. We'll start with a base image that has a Node.js. Then we create our own custom image by adding the application files and dependencies like we have it in this Docker file. Then we'll use this image to create containers that will run our application. So if it's still a bit technical, I can go a bit more real life. So let's say that let's think about a Docker image as, let's say, a recipe for a dish. When we're looking at want to cook and we have recipes, we have instructions, right, in the recipe. So measure maybe 350 ml of the water, put salt, whatever it says, right? So it also lists all the ingredients in that recipe. It tells you the ingredients. So let's say the ingredients are dependencies. Without ingredients, can you cook? You can't. So you need dependencies for your applications and step commands and steps. So like those steps, it's listing those instructions are the steps, right? Take them as commands. That's what we have in this Docker file here, like work directory, copy, run, cmd. That's what it means. Now, you need those things to prepare the dish. And the dish in our own sense, let's say the dish is the application we want to package and all of that. So every time we use this recipe, right, for our food, we create a new version of the container, which is like of the same dish. God, I hope I'm not confusing you guys. So we can create a new version of like a container. And the container in this sense is like our dish also, right? So that's how it works. So also, if you use like, I'll show you guys. There's a way Docker saves, like if you're using a base image, like now I'm using this Python 3.8 for different microservices. Docker will actually only download this base layer once and store it. So you can reduce the layer without you having to build and download every single time. So Docker has a very, very good caching strategy, which is why it is very efficient. Now moving on to Docker images. I'm sorry, Docker containers. So a Docker container is just what? Is a live and running instance of a Docker image, right? So it's like taking like a blueprint of like an architect designing a blueprint for you. That blueprint the architect designed is the image. And then you're using it to build a house. You're putting blocks, you're laying your foundation. So that is the container. So as it says here, it's like taking a blueprint, another word, image, and building an actual house container from it. Containers are isolated environments that run your applications along with its dependencies. They behave like lightweight, self-contained virtual machines, but are much more effective. Now, characteristics of containers are: one, it is ephemeral. When we say something is ephemeral, we mean it's temporary by nature. You can stop them, you can start them, you can delete them, and nothing will happen to your image, right? So each time you start a container, it's a fresh instance of that image. And what did we say containers are? A container is a running instance, but it's a live running instance of a Docker image. And it's also very portable, right? Anywhere you move demos, development, staging, production, it all works the same way. Now, a use case for this is, let's say we deploy a web application in a container, and that includes our, let's say, web server and code and everything. So even if we stop that container and we delete it, the image that we have built will still remain the same. And I can always use that image to spin up a new container. That's how it works. Now, if let's say, where is that our recipe that we're talking about, right? So we said our Docker image is the recipe, if you remember. Then the Docker container is the finished dish you serve on the table. Just take it like that. You understand? So the Docker image is the steps for you to, is the recipe for you to create the meal, and the Docker container is the finished dish. So every time we run the recipe, which is our image, we get a fresh working instance container of that dish, and the dish in this sense is our application. So And containers also run in isolated environments, meaning the process inside container A cannot affect anything inside container B or even your host system, but they share the same OS kernel, which is where they are very, very efficient, more than VMs. Now, we talk about Docker files. So a Docker file is just a simple text file, honestly. I'll show you guys how to create one, and all you need to name it is Docker file. There's no dot anything, no extension, just a Docker file. And it contains a list of instructions, just like it looks here. These are instructions, 5 lines, right? And these are the most popular instructions to build a Docker image. So we use Docker files to build a Docker image. Don't forget, guys. And a container is a running instance of this Docker image. So we have this, right? Is that we said is an instruction, is their instructions. This from means the base image we want to use. There are so many images out there. I think after the slides, I'll show you guys the practice when we're doing the hands-on. You can go and look for Node.js. So you can look for and the images are according to like programming languages, right? Sometimes Node.js, anything you're looking for, you can look for. So I can't even remember some of these frameworks and all of that. Sorry, guys. Apart from Node.js, Python, there's so many. I just can't remember that. Anyway, so that's what it does. We use this from to specify the base image. Then we use copy or add sometimes. We copy files from our host into the container. So this copy files from our host into the container. Who can just give me an example of what I mean so that I know that somebody's understanding what I'm saying? So when you an example, we copy or add from our hosts into the container. And this is a command, right? This command means copy, dot means copy all. That's what dot means whenever I see dot somewhere. Copy all into this directory called /app. Who can tell me what this means? Anybody? Ladies, we did Linux with people. You know. Okay, let me go back again. From Python 3.8 slim is what? Base image. We are taking, we say from this base image, then we say this work directory. Who remembers mkdir? It's very similar. Create this work directory /app. Copy from this directory into app. So what is it copying? Somebody tell me what it's copying. What is this all, this dots that we say is all? What is it copying into that directory? If you don't know what it's copying, I am just going to go, maybe I just can't hang myself today. What is it copying, ladies?
In Linux.
Not in Linux. We've been speaking about Docker. We said, what did we say Docker is to do?
Is it the image?
Absolutely not. This Docker file is to build an image. So what image is it copying, Mary, when you have not built it?
The code.
Thank you very much. Like, oh my goodness, you want to give me a heart attack this morning. It is copying the code. That's what it's doing. All the files in your system, it is what it is copying into the directory called app. My people, please. Thank you. So after it copies the code into this directory, it now installs requirements. Everybody knows, not everybody knows, sorry. For those who have built Python, Python always has requirements, right? Later on, we're going to be deploying a Python website with you guys. It has requirements. So things like the versions. If you use, is it Gonicon? If you use Sentry, there are so many tools, right, that developers use to build. So those things, those dependencies they use to build their system, they need to come and specify all of them in this requirements.txt so that we'll not have the issue of it's working on my system, it's not working on my system. Give us everything, how you use it on your system, and just package it for us there. So that's what it means. Run pip install -r requirements.txt. It will install every single requirement you put in this file in that container. Then what? It says cmd python.app. Later on, I'll explain what cmd means. So, but they're just commands that will run when the container starts. So this CMD now means using this Python, right? Run app.py. So that might be, there's the same way we used to run index.html and all of that. Don't worry, practical will really be better. Then we have Docker Hub, right? And the Docker Hub is a public registry where we can find pre-built images shared by the community, blah, blah, blah. So now if I come here and I say Docker Hub, it's a library literally for all the images. The same way all of you have your pictures on Instagram. Just think about how this is a library for you. I can find so many images. Like you see, if I'm into machine learning, there's TensorFlow image, PyTorch, blah, blah, blah. So many things I can find, right? So that's what it's for. We can pull and push images, right? We can pull and push images from Docker Hub to use them locally. So now if I want to use this TensorFlow image, all I'll need to do is enter here. I'll enter. You see it's Docker pull. I'll just, if I pull this on my terminal now, I've pulled the image and that's it. And we can push also. If we have our code base on our system, like now this file, after building the image, I can push it to this Docker Hub and I can see it there and everybody else can use it too. But if I leave it on my system, it's for me and only me. If I don't push it to a hub or a registry, GitHub has a registry, Docker has a registry, and there are much more. If I don't push it, how will my team members access it and use it, right? So that's how it works. And I have I said a use case, right? If you're, instead of building your own Nginx server image from scratch, you just pull the official Nginx image from Docker Hub and you can start running a container with it. I'm trying to think. Mary that says she's confused. Let me see how to help you. In fact, Mary, I don't know. When we go to practical. I'm sorry, it's not Mary. It was Folashade. When we go to practical, we'll see how to do it. Then the other components are Docker Engine, right? Docker Engine is the whole technology behind Docker. It is the underlying platform which makes the Docker containers work. It is the software itself, right, that manages the images and containers, network and volumes and every single thing. That's what a Docker engine is for. The key functions there will be container runtime. You can run and manage your containers. You'll see how to do that. Image management. We said you can download images from Docker Hub. You can also push your own image. You can delete whatever you want. Then networking, to manage containers network, because your containers will need to be able to communicate between each other. Even though they are isolated and they are independent, they should be able to communicate to each other. And then we have the Docker CLI, which is the command line interface that you use to interact with your Docker engine. So there are different commands you can run in the CLI, like Docker run, Docker build, and all of that. So use cases like when it is the engine that powers all your operations. When you type Docker run in your terminal, it will spin up a container, isolate it, and connect it to the network. That's what it does. So I want you to think about Docker engine as the kitchen appliance. Without a pot, please tell me which food you want to cook. You cannot prepare any dish. That's what it does. So it's the main thing, right? And then we have Docker networks. Docker networks, there is to enable communication between containers and the outside world, like I mentioned. There are different types of network. There's a bridge network. That's the default network. Any container on the same bridge of network can communicate with each other. There's the host network. They all share the same host networking stack, as long as they're on the same host. And then there's the overlay network. I will not even talk about this because I don't want to do container overload, right? And a use case for this is, let's say in a microservice architecture, we have one container running a database, and then we have another container that is running the backend API. How will the backend API talk to the database if you don't establish a Docker network? So once all of them are on the same network, they can communicate with each other over the network. You understand? So let me see, an analogy, let's say, is that there are hallways in an office building, right? Each room is isolated, and the isolated rooms are our containers, right? But the hallways, if I enter a hallway or a corridor, I can go to another room now. So that hallway that we are all passing to enter a room to the next room is the network that allows communication between all containers. So next up is volumes. Volumes are used to store data outside of the container file system. So we need to ensure that it like data persists even when container is stopped or deleted. And why we said so is containers are ephemeral. What did we say? Containers are ephemeral, which means they are temporary. You can delete them and all of that. And any data in that container, once you delete it, wallahi otilo, it don't go. It's not coming back anywhere, except you highlight like a volume to use. So it stores your data to that volume. That's why we said providing persistent storage, so that no matter what happens, your storage is still there. And those volumes can be shared between containers. So multiple volumes, maybe deploy the database or something. I don't know. But that volume, that SQL database, let's say we are running it in a container. You would need a volume to store the database files, so that in case if that SQL container is stopped or deleted, your database can still be found on that volume in the VM or something. If not, it has gone. So also it's like a volume is like some of us might have a separate hard disk or flash drive, right? So that we used to save some files. And anytime if you carry my hard disk and I connect it to Salima's computer, it would work, right? So the data will always be intact and we can always access it on any computer. That's the advantage of having a volume. Anyway, next up is the summary, and then we are done. So we said we use images. Images are for what? Blueprint for containers. Containers are what? Running instance of the Docker image. Docker file is the set of public instructions to build a Docker image. Docker Hub is the public repository for sharing and downloading images. Docker Engine is the technology that runs Docker. Networks connect containers to each other and to the outside world. Volumes to persist data outside of container. Ladies, look at this very well, because we have a lovely quiz at the end of the class. And this quiz will be used for your final assessment too. So thank you very much to all of you that were listening with one ear. Surprise, surprise. So now that we have all of this theoretical stuff out of the way, let's move on to the fun parts. So, number one, I need to share my notes. Sorry, I have to move it to another tab. Blah, blah, blah. Can you see my notes? Maybe can you see my screen?
Yeah, we can.
Which screen are you still seeing, please?
The one with your Google Docs.
Perfect. So this is the fun part of it. So I wrote this is a note I created for you people. And guys, I was stressed. If you notice, I'm not really a slide person or note person, but I had to do this for you just so that I wouldn't hear, oh, I didn't get this, I didn't get that. So this is really in depth and you can always read it. I summarized all the things you need so that in case if you go online and there's information overload, this is enough. This is for you to suffice. So, but we're going to be running through all those things today and yeah. So first thing, you have to install Docker. My ladies, you have to install Docker on your computer. If I go here and I say set up Docker or Docker installation, anything you type, so you get started, or you can go to this install Docker. You can learn how to install Docker or you download Docker desktop. So For people on Mac and Windows, we need to get the Docker desktop application. I think Linux should don't need it. If I even go, I don't think you need desktop. Yeah. For Linux, all I need to do is run some commands and that's it. You don't really need the desktop thing, but I think you can. I don't know. When I was using the Linux environment, I didn't need the whole desktop setup. But on a Mac environment, you need it. On a Mac environment, you need it. So once you go to this Docker desktop, you see, they talk about it as a one-click installation for your blah, 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 that lets you build, share, and run containerized applications and microservices, right? It provides a straightforward graphical user interface that lets you manage your containers, applications, and images directly from your machine. Funny thing is that I swear I do not use the Docker desktop like that because I came from a Linux environment. I am so used to doing things on the terminal. In fact, today that's also what I'm going to be showing you guys. That's also what I'm going to be showing you guys. I think, but I'll show you how the desktop looks, but we're not going to be working on it like that because I'm not used to it. I'm a very, what do you call it? Anyway, so to install, you can come. I can click install desktop on Macs, Windows, or Linux. I will let you guys do this. It's not my problem because I have it installed. So I'm going to link it here for you. Later on, you guys can do this. So, yeah. After installation, you can run this command to check your version. So let me pull up one of my terminals to my screen. Yeah, so this is a very fine terminal I use. It's called Warp for anybody who wants to know. The reason why I like it is endless. So if I want to just confirm that my Docker that I have installed, after installing and setting it up on your system, I can just say Docker version. And you see what it brings out. It tells me, okay, I'm using version 24.05, API version this, that. All gives you all information. The server, when I downloaded, and it gives you the verbose command. But if I say Docker, guys, be careful with spelling error. I swear I don't know what's wrong with my hand today. Why are people leaving the call? So if I say Docker -- version, all right, that means give me a very cute one-liner version of what I'm using. I don't want all this information. Just tell me what version it is. You see, there's a difference. This gives you verbose if you use Docker version, but if you use -- version, it means please cut all the nonsense content and give me something cute and small. So moving on, if now I have this, and I told you guys I had a Docker desktop, you can see it down here, right? And I pull up my Docker desktop. Okay, I have to move it to the screen. Okay, let's say this is my Docker desktop. Can we see it? Yeah. This is my Docker desktop and all of that. If I come in, I can see this place containers. They have learning guide. I tried some of them yesterday to just see what it looks like. Maybe something we'll do today. I think we can run one or two. So you see containers, you see images, right? How many images I have, the hub. I can connect it to my Docker hub, Artifactory, and all of that. Then the volumes, right? To store data. This dev environment, they say it's still in beta. I have never even tried it. I don't care. And the learning center, they have so many things. They can teach you so many things here. So after I finish this class, please everybody go here, read them, try them out yourself for practice. So we can go through the walkthrough and all of that. I can't remember which one is first though. I think what is a container? If we go through this, it says creating a simple project for you to explore what Docker Desktop can do. So we're going to run a few of this what it's telling us here. And then we're going to try our own commands separately and deploy some applications. So I think my internet might be a bit bad because this should not be taking too long to load. Okay, we're in. So yeah, it says the best way to learn about Docker containers is to first see it in action. We have created a welcome container for you. You can check it out. So while I started that lab, they already created a container for me, and this is it. This is the container name. Welcome to Docker. This is the image. Remember that we said that an image is a what? A container is an instance of a running image. So this is the image. Docker. This Docker is the name of the like a user or repository. Then the name of the image is welcome to Docker. They tagged it latest. The status, we can see that it's running. CPU consumption 0. This is the port. Do you guys remember what a port is? Who remembers what a port is? Ladies, what is a port? You did this last week. I was a witness.
Psychological access door.
Yep, it is the access door. So for those of us who maybe didn't get it last week, I'll use an analogy. Let's say I am a baker. After spending hours baking cake and all of that, and I need the world to see my cake. A port is just like opening the window and then putting the cake by the window for people to view. If I don't open the window, will people see my cake? They can't see it, right? And I want people to see my cake. So I need to open the window for people to see it. If I don't, people cannot see it. They cannot access it. So a port is just like that. It's like a door for people to view, your deployment, for you to give access to the external world to view it. If not, it is only you and your system that will see it. And that's not what we want. So this port was mapped. My local host 8088 to port 80. So we can keep going. It says view the front end. This one is a simple web application. Select port 8080 in the port column to see it running. If I click this port, sorry guys, let me open it on here. If I put the URL here, you see what we have? Are you guys getting this? This thing now that you're looking at was a code that somebody built, but they packaged it as an image. And look at just it. Look at how easy it was. They built the container for us. We have the image. We click the port. We can see it. Local host is accessible, right? Next, it says explore your containers. Containers are an isolated environment to run any code. We already know that. Moving on. It says stop your container. A container runs until you stop it. Do this by clicking stop on the container. You see there are actions on this Docker desktop. You can either press yes to stop. If you press here, you can see more action. You can see it in the terminal. You can copy commands, you can view, you can pause, you can restart, you can do whatever you want, right? So I'm just going to stop it. But guys, I told you this is using the GUI. I will teach you people how to use the terminal because I promise you that is the solution in this world. Because there's instances you will come whereby you wouldn't be able to access this GUI if you're, let's say it's on a server or something, right? Anyway, so that's how we create containers, and then we can end this lab. Next up, it says that we can run Docker Hub images, right? You can go to search for the image, run the image. Nah, I don't think we need to do this. How do I run a container? How do I run a container? Images are used to run containers, right? And it says in this guide, you create an image using a Docker file and a sample application. So now it says get the sample application, clone this repository. Let's first go and look at, let's go to this link. Let's go to this link and view the application they are telling us to clone. I don't have access. Interesting. Okay, yeah. That's funny. Let me open an incognito tab. I don't have access to this. Do I need to log into my personal GitHub account? Sorry, guys. Let me try in my personal window. Okay. Okay, I actually can't access it. Okay. It's not about this. So I can access this repository. But what I can do is we can clone this, right? So if I say I copy this command, now I don't know, should I show you guys on the terminal? Let me open up an editor. I use cursor editor. I'm going to close this terminal off. Which what do you guys use? IDE. Do you use Visual Studio Code? Which one
Visual
exactly?
Studio.
Visual Studio Code. Hi, ladies, can you hear me? Am I breaking or is it?
Yeah, I mean, I can hear you.
Okay, that was my internet. So you use Visual Studio Code, right? So some of you be using Sublime, maybe Atom. I use Cursor. It's a new AI. It's a new AI. What do you call it? Tool, right? It is the way, guys. I'm giving you this hint. You can ask it for prompts. It helps you a lot. It even helps you debug your code. I swear to God. To me, I feel like these AI tools just benefits. Let it help you automate things, reduce the time you spend on so many tasks. So I use Cursor, but I also have VS Code, but I moved to Cursor recently. So when I open up my Cursor, I need to open a tab. And I created these DevOps classes when we started. I think the first day we did Linux, this was what we used. So I'm going to be using this. And remember how we do it? Print working directory. This is the path. So save, download it too. And you can also download, you can use this thing, Cloud. It's a good AI tool for coding, better than ChatGPT. I call it Claudia though. What is what it's pronounced? It's French. Yeah, Felicia, yes, Closer Visual Studio Code, they are all IDEs, which means, what will I even explain an IDE for? So they're like tools, right, or editors. It's an integrated development environment. That's what an IDE means. So it just helps you code your software and everything. That's what it means. So they're all IDEs. They all do the same thing. But Cursor is one of the best because of the whole AI integration it has. It's been trending. I don't know, maybe some of you would have seen it. So Claude is a large language model. The same way we have ChatGPT, we have Gemini. Claude is also another one, but it's mainly concentrated towards technical tasks. So yeah, we have our DevOps classes, this directory, right? Remember, guys, if I want to clone, I've copied this cloning command. What do I do now? How do I clone? Who wants to teach me? Who wants to teach me? Sorry, Mitty, I didn't get that.
Git clone the URL.
Okay, so I should just paste my command. After this, then what? Just enter. Yeah, git clone. Then the URL we're trying to clone, and I'll just enter. Is that it?
Yeah.
Thank you very much, which is correct. We have already cloned it. You notice this command has finished running. Who noticed something else on the screen changed? Who can tell me what changed? Goodness, don't talk. Anybody else? Tell me what changed.
Cloned repo has been created. Welcome to Docker.
Where is it? Can you show me where?
Inside the DevOps class directory.
You can see it here, right? You see, guys, it already popped up. And if some of you like CLI, you can just say ls, right? And what do we have? We have the directory here. Now, welcome to Docker has this following files. This is a folder. This is a folder, Flavicon index, blah, 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 blah. So this welcome to Docker. Do you guys know that it's the same thing we saw that first time we ran that image? It's the same thing. And remember what I told you, this is their Docker file. Their Docker file is a set of instructions to build a Docker image. They have this JSON dependencies. These are the dependencies we were talking about, guys. So imagine now, I just carried this folder and give it to Safe to go and run on her own system. Then Safe to come back and tell me that it did not work. Probably because maybe my own system is not compatible with this dependency. Who knows? It's possible, right? So these are dependencies. Your code will always have dependencies. These are scripts that need to run and all of that, right? So this is now the folder. We have cloned it. So don't worry, guys. I'll go ahead and explain what this means later. So I've cloned it. Next, it says that we should verify the Docker file. So open the sample Docker file in our IDE. Note it already has a Docker file. For your own projects, you need to create this yourself, like we said. They have created this for us, but we need to do this. What does this command do? It starts our image with a base image. We have said it. A node based image. Earlier on my slides, it was a Python based image. This one is for node. The app directly should act as the main application directly. That's what this work_dir/app means. Copy the app package and package JSON file. This package.json is what? This one here and this one. So it says we should copy the app package and package.json file, copy local directory to the current local directory of our current image Docker app. And the local directory is what? SRC. All the files in SRC. It says it should copy it. Are we getting this? Then copy. It says this copied all in SRC. It means copy it to another file on the Docker container. That's what it means. So don't be confused. This double SRC. Copy our own SRC on our host system to this /SRC on the container. Copy this --public on our this detail receipt. Copy this to our another directory called .public. That's just what it means on the container. Then there are packages it wants to install. Sometimes you need to install some packages, right? And what's it? You need to npm install. I don't know who has ever deployed an npm app here. Anybody? Anybody? Yes, goodness.
You said who has installed it, ba?
Yeah, who has ever deployed, sorry, an npm app?
Eh?
Who has ever deployed like a npm app? Have you done that?
No, I just installed it. NPM installed.
Okay, installed it, right? Oh, okay. So when you that's you need to install npm before you can run the app. You can build the app and you can even deploy it. So this is for front-end developers, right? You have to install it first. The same way you would do on your local terminal is the same commands you have to add here. So you say install node packages. npm means node, oh, please. Then npm install -gserve. That's one of the components in npm. Then run build. So when you want to do this on your system, these are commands you can just run in your terminal if you are testing locally. But because we want to containerize, we want to package everything. We don't want to leave anything outside. That's why we're doing it like this. Then after running, this run build means to build the app. Then after we finish, it says remove the dependencies at the end. So that's all these things we installed. Please remove them. Expose port 3000. We all know what that means, right? Thank you. Then we start the app using the command and we use the serve command. This is an npm component, like I mentioned, and we want to build it. So ladies, this thing does not, I'm not saying that you need to know how to write a Docker file yourself, right? Here's the funny thing. This Docker file that I have, it would work for, if I have another node application, it will work for it. If I have a Python application, I have some template Docker files I can use. It will still work for it. So it's not like you need to write these things yourself, but you should know what they do. And also, with the help of the large language models we now have, these are things that they can write it for you. I can just go to ChatGPT and say, write me a Docker file for a Python app. And it will give me a Docker file that I can use for my Python app. I didn't need to write this. I didn't need to like do it, myself, write it from scratch. So we have gone through the Docker file. Next up, it says to build our first image. Now, Docker has commands, right, that we can use. And Docker build is how to build an image. So if I copy this command now, what does this mean? Docker build is the command. -t means tag. -t means what? Tag. Please don't forget. And I want to tag this image, welcome to Docker. I can tag it whatever I want. I can call it my name, but it's good to call it something that when somebody sees it, they will know what it is, right? And who can tell me what this dot means, please? Okay. This dot means in
The
this
code.
directory, not the code, though, not the code, Mary, but in this directory, I want you to build the Docker file in this directory. If I run this command and I press enter, it will fail. Who can tell me why it will fail? Anybody that tells me why, I promise you data. I promise you data for next week.
Come again, please.
If I run this command, it will fail. Who can tell me why?
You don't
Let me
have your Docker image name. Is that it?
Docker image name.
ID. Your Docker
Not
ID. Image ID.
Not really. Not really. That's not it. This
You're
welcome.
not running it inside the directory that you joined.
Please, can we clap for Mutia?
Ah, ah.
I need to clap for her. I am not running it. That's why I quickly moved from my screen because I know it had told you here. I don't know if Mutia saw it though. It says error, failed to solve, failed to read Docker file. Give me some error. It says what? No such file or directory. DevOps classes is my root, is the directory I'm in. If we say ls, what's inside? Right? Until I do cd, welcome to the folder. The directory my Docker file is, I cannot build it. And if I go back and I run this command, it would work now. So you need to be in the directory your Docker file is, because we're telling it to build the Docker file, but the Docker file is not, I'm not in the directory, so how will it build it? It wouldn't work, right? Metia, please come and claim your data. Thank you very much. So that's how it works. Now we've built our image using the what? Docker file. Next up, we can run, they say once the build is complete, an image will appear in the image tab. So if I go to image here, I can see it, right? And I can select the run option to run it as a container. So should we go and do that? After that, it says we should view the front end using the port. Well, I finished this. So let's go to the image part now. You see the image we just built? This was the one they built for us earlier from the container when we did that lab. But this is the one we built ourselves from the terminal. And what did it say? It is unused. That is because it has not been linked to a container. We need to link it to a container for it to run. Now, you see the size also? 231 MB. So if your Docker size files are huge, you need to cache it, but that's later on. I think in future we can discuss this. So now if I click this and I click actions and I say run, it's going to ask me settings. What do I want to name the container? Let's say test DevOps or something, right? Do I want to map it to any port? If I say no, do I have volumes? I want to add no. And sometimes you need environment variables. Guys, notice, for those of us who have built applications, sometimes there are variables your applications need to be built with, right? Things like maybe if you have a Flutter, if you have a payment gateway, you need to add the Flutter wave, key, and everything. You build Docker files with environment variables that need to be passed on runtime. When I say runtime, I mean when an app is about to run, it needs some variables, some passwords, some things, right, to build. You need to build your Docker file with those things sometimes, but it is not every file, every app this applies to. It depends on the kind of app you have. So please let me not hear excuse that you don't know how to do this. And this anything we do here is what you can do on your Docker file too, right? So if I say run this, it's already saying it's accepting connections at HTTP. This is my logs, right? So let's say inspect, I can see this bind mount, we have no volume. This terminal is the container itself. You know how you cd into a directory? This one we exec into this directory. We'll talk about it later. Then we have the files. The files here are the files where, that's the files from our code base. You see them here. Remember our app, remember that build we packaged, look at it here. Remember the package log.json, remember src2, remember public that we highlighted here, public, look at it here in this directory called public. because we wanted to match it to what was here. Remember SRC? Everything in SRC that we mapped here, everything here, you look at it, it's here. That's just what it is. So we've packaged our whole application and now it's here, right? If I go back and I go to containers and I want to view this, our test DevOps, it's running now, right? And okay, we didn't bind the port. We didn't bind the port, I see now. Okay, sorry, ladies, we didn't do this. I can stop it, but I'm not doing that honestly. So I can't access this because we didn't bind it to our local host. So we understand how to use the GUI of Docker Desktop. You will not see this again till the end of this class. I am leaving. Now let's get to work. Where's my document? Any questions though before we continue, guys? Any question? Any question? Any question? Or should I just keep going? Give me a thumbs up, thumbs down, and thumbs up from Safe. Goodness, yes, please.
Okay, so my question is this: using Docker Hub to run your container and then just running it with the public Docker repository. If you have your own private Docker hub,
Mm-hmm.
don't know if you understand, you have your own private one and then using the public Docker hub. Is there any issue with using the public one?
Okay, so first of all, the Docker Hub is where you store your, what do you call it, your images, right, and all of that. Now, on this Docker Hub, there are public images that anybody can access, and there are private images. You can have a public account and you can have a private account. You can make your image private. Now, for example, goodness, you're working for a fintech company, and they have maybe an image called user account numbers or something. Will that image be public or private when you want to push it to Docker Hub? What would it be?
Come again, please.
You're working for a fintech company, right? And part of their microservice is one called user accounts or something. They have a database and everything there. If you want to build that Docker image, would you make it private or public when you want to push it to Docker Hub?
That's my question because I don't know.
I'm asking you.
If is it not possible to do both? Like you can still push it to public and you can push to private.
So if you push it to public, you can do both too. You're free, but just know that you go to jail. You know,
Hey,
you will go to jail because it is private information. I said you're working for a fintech company and they have a microservice that builds payment. I'm sorry, that has user accounts and database, and then you make that Docker image public. I can go and carry that image. I can view all the content in that app. Goodness, I will see it. And if there are maybe environment variables there, God should do it for me. I can access it. I can copy, make a scan. Next thing we hear, goodness is in prison. We'll be like, and justice for goodness. We'll say we don't know who that is. Do you know goodness? No, we don't. That's what will happen to you. So you can make your image public, but make sure it's an image that has nothing you are risking, right? But if it's something with private, or if it's an organization, private data, you can make it public. Just good luck to you. So you can choose the one you want to do. But if you are using a free Docker Hub account, I think they only allow you to have 2 private images, but the remaining has to be public, except if you are paying for it. So there is a way for them to also make money from this thing. So thank you. I've answered goodness question. In the same way, some of you are using my Slack webhook URL on your GitHub repository. That's how they'll arrest you too. Moving on.
Can you hear me?
Sorry? Yeah, I can hear you now.
Oh, okay. So I was saying that on this Slack webhook thing, yeah, I don't know why. Is it that it doesn't happen to you guys, or like what's going on? Because last week, I think when I was trying to push from my VS Code, yeah, because that was what I was using, and I was trying to push directly to GitHub. Like after I did my whole add commits, I was just about to push, and then it refused to push. So I don't know how you guys are even able to push the webhook.
Okay, it
to
told you that it was vulnerable and it didn't
yeah,
accept
there
the
was
error.
like an error. It kept showing an error. Like I even faced this problem
Wow.
since till yesterday because I had to now move it to an environment variable, and then I didn't
Yeah.
ignore that environment variable. It still kept throwing the same error that I cannot push a webhook URL to GitHub. Like, so I'm surprised you guys are even able to do that.
Slack has a very good security feature. I don't know.
Yeah.
For last day, you could come and explain how I put in it.
What are you people doing? What did you people do? Sorry, you can
Because
continue. Yeah. I just
once
wanted
that
to.
once it's live on that public on a public record, they immediately send me an email telling me they are taking it down. That's what they do. And so yeah, we'd love to hear Shade later, maybe how you guys are doing it. Anyway, so we said we should run another container. We saw how to run one container from the GUI, right? But as I said, I'm a terminal baby, so terminal we work with. Hello World is an image on Docker Hub. It is the most popular. I think Hello World is the most popular programming I don't say language, but like a slang. Your first code, Hello World, everything Hello World. So literally, Docker has an image that they have already built, though, and it is called Hello World. I think you've even searched for it here. Let me see. Let me go to Docker Hub. All right. If I search for Hello World, you see, I have it here. The image has been built, and what did they say? It's a Docker official image. So it was built by Docker themselves, and it's one of the most popular. It's what people use for examples. So you too now you can build your image and you can see it like this. Later on, we'll build one that you will see. So Hello World is there, and then to run this, right? We can say I think I have to explain this to people. So yeah, what does it do, right? It will pull the Hello World image from Docker Hub. Look at it here, I think here, right? If I say Docker pull, I can pull the image, but if I pull this image, I'm not running it. So I want to run it. So okay, let me give you guys a hint. If I say Docker pull Hello World, it's just going to pull the image, but it will not run it for me. But if I say Docker run Hello World, it is going to pull and run the image at the same time. So that is why I'm using this command. Just know this, right? So, and then Docker will create a container and from the image and run it. This container will print a message and exit. And while it is exiting, is because that is how it was like, will I say built? And I'll show you guys why I said that's how it was built. So this hello world is just meant to, I think it's Docker. Sorry, let me clear my screen. So we don't want to do it in this welcome to Docker, right? So we can leave this directory so we don't mess things up. So I can just say Docker run hello world. Enter. So what did it say first? Unable to find image hello world latest locally. Do you know why it does that? Because remember earlier I said Docker caches things for you, right? So if assuming I said if we had this image locally, it would not build it, it will not fetch it again. There's no need because I already have it. So first thing it said is I cannot find this thing locally, so I'm going to go ahead and pull it from library. Hello world. Pull complete. What did it say? Hello from Docker. This shows that your installation appears to be working correctly. So this is what you use when you want to test after you have downloaded Docker and you want to test everything works. You can run this image to test it. And once it printed this message, what did it do? It exited. I think you understand what I mean by it exited later on, right? So we have this, and this means that your Docker is working very well. Now, this Docker run IT Ubuntu bash, this IT means, is it interactive terminal? Yeah, that's what it means. So do you know how the way I told you that you could exec into something, that you could exec into a terminal of that container? That's what this does for you. And it's telling it to use Ubuntu as a host and a bash system, right? So, and this, we're not doing this today, please. This is a bit advanced. So now that we have run our hello world, we now need to view, let's say we want to view our running container, right? Running container, what do I mean by running container? You can tell me. What do I mean by running container? Anybody? Let me pull this up higher. Yep. So by running container, what did we say? A container is an instance of an image, right? If remember that container Docker built for us earlier, 2 containers, right? If I say Docker PS, what does it do? It returns welcome to Docker latest. If you check here, what did it say? Names, test DevOps. Do you remember this one? It was the one we built. This one here. This image that we built, that was the one. This one we built up here that we cloned. Then we ran the image. That's the one here because we named it test DevOps when we ran the container on the GUI. Now, who can tell me why is it we cannot find this one that we just did now, this hello world? Why didn't it appear here? Anybody?
Because we didn't build it ourselves.
Because you didn't build it yourself. Wow. Didn't we just run it here? Okay, because we didn't say that build-t Docker file. Actually, that's not why. Because Mitia, the reason why we said build-t is because we were building a Docker file, right? But because we have an image that we're pulling from Docker Hub, that image that was pulled from Docker Hub was also built to the Docker file. But because it's not our own, we don't need to build. But that is not why we are not seeing it here as a container. In the chat box, I am saying we did not run it. Falashade, what is this? What was this command here? Docker run hello world. Did you see something else when we were running our own command? You said we did not run it. We ran it now. But there's a reason, and I spoke about it. There's a reason.
You said we didn't bind
why we're not. What do you say? Because I swear to God, I said it. Guys.
Like
you,
it's not
you
locally
mentioned something like
that-
binding something.
I can't hear both of you at the same time. What do you guys say? Do you
because
remember
we
when I
didn't
said,
locally fetch it on the system.
nope, that's not why. Do you know what happened? I said it. I said that this Docker run hello world, what does it do? It prints a message and exits the container. As I've said it now, who can tell me why we're not seeing it?
It's not in use.
Thank you very much. Yeah. It is not in use. All this does is print, it just prints this and says bye-bye. This Docker PS is to check for running containers. Now, if I say Docker PS -A, who can find it here? You see it here? Hello world. It's there. What did it say? Created 4 minutes ago, exited 4 minutes ago. It's not in use. Immediately we printed this message, we stopped it. It was stopped. That's what the file, in their Docker file, that's what they said it should do. So we would not see it in Docker PS. We only see it in Docker PS-A, and which is all our stopped containers. And these are the stopped containers. This one is the one that Docker created for us. This one here, it created for us, right? And that's how it's not more. If I go to the GUI now, you see that this one too has been stopped. It's created at 3 minutes ago. It exited 30 minutes ago. So now there are 2 commands. Docker PS to what? Check your running container. Docker PS-A to check stopped containers. Do we get this? Hopefully we do. Now, if we want to remove a stopped container, right? Because, for example, there are times whereby you will use, what do you call it? Let me go to Docker PS-A. Now, let's say I don't want this hello world anymore on my laptop. I'll be on my, this is actually on my system. I don't want it anymore. How do I now delete it? It says we can use the command rm and use the container ID. If you check here, you see something called container ID, image, the command. This command is what is running. You remember this place here, this CMD? Whatever is running here is what's here. Created status and all of that. This is the image name. We cannot use image name to delete a container because an image name is not something that can be unique. We can have multiple images with the same name, but this container ID will always be different. So now if I want to delete this hello world container, all I need to do is docker rm from the word stands for remove, and I paste the ID and I say enter. You see, it returns back the ID. If I say docker ps-a, do you see it there? It has gone. And that's how to delete a Docker image. I'll be sorry, a Docker container. This is a Docker container, guys. Please, there's a difference. And if I say Docker PS now, if I want to delete this Docker container, what do I do? Who can tell me? I want to delete this one that is running. What should I do?
You have to stop the container first.
Thank you very much, goodness. We have to stop the container. If we don't stop it and we just say docker rm, look, and I copy the ID and I paste it. What did it say? You cannot remove a running container. Stop the container before attempting removal of us. So what I have to say docker stop. And one thing about Docker Hubs is the components, what do you call it? CLI tools, I mean CLI components, they are very, very understandable, right? It's something that you don't need to crack. They stop, RM, PS, all those kind of things. So if I say Docker stop, it has stopped the container. Then I have to what? I can say Docker RM, container ID, and it has gone. If I say Docker PS now, we have nothing running anymore. We have deleted it. Also, if you have plenty containers, you can delete more than one container at a time, right? So imagine I have, if I say Docker PS-A, let me run my hello world. Let's run hello world again. Docker run hello world. So I want to run this again so that I can have another image. So if I say Docker PS-A, I have two containers here that are stopped, right? If I want to delete these two, imagine I have 5 containers and I'm carrying them one by one. It's a waste of time. All I can do, I can also say docker rm, first container, I carry it. I put it here. I carry the ID of the second container. I put it there. I delete. All of them have gone. If I say docker ps-a, is it there anymore? It's not there. And if I have like maybe some of you that are very dangerous people, if you want to delete all your containers in your system, you can just say docker prune. Look at the docker container prune. So this will delete every single container on your system. That's why I say if you're a very dangerous person, maybe like goodness, you can try this out. Hopefully everything goes well afterwards. So we're moving on. We now know how to, what we did in the first part is we know how to run an image, right, from Docker Hub. We know how to list our containers. We know how to also list what do you call it? We know how to list the stopping containers. And funny thing, remember, this is containers. Oh, these are containers that are running the image. If I say Docker images, yes, I'm still sharing my screen. I hope everybody can see that. Can anybody confirm they can see it? Maybe I have, okay. But I think maybe internet, or you can leave and come back again. So ladies, I said, if I want to see my images, I've shown you how to see containers. If I want to see my images, all I need to type is Docker images. And it lists all the images we have pulled. Because you delete a container does not mean you have deleted an image. There are two different things. Your images will always be there unless you delete them on their own. Because you can use an image to run a container, right? So they are more important. So look at all the images we have. We have welcome to Docker, the ones we did from the GUI, and then this hello world image. They are all available. So that's how you list your Docker images. I'll show you guys later on how to delete those ones too. So now we want to pull and run a pre-built Docker image, right? So like a simple web server, I think most of you would have heard of Nginx, right? Nginx is a web server. So to run this, I can use this command. This engine X here, if I go here and I search for engine X image and I say engine X, look at it here. This is the official image of engine X, and you see what it's called? Engine X, right? So if I say I want to run this command, now let's talk about this command. This -d means detached mode. It means in the background. If you don't use -d, I'll show you what will happen. This -p, it means to map a port. So I want you to map port 8080 on my local system to port 80 in the container. Engine X listens on port 80. Do you guys understand? Most of these servers, applications, if I want to run a Flask app, it will listen on port 5000. If I want to run a Engine X listens on port 80. And I'm telling it that map this Engine X port 80 to my local system on port 8080. If I don't do this, I won't be able to view this file. I won't be able to view this file. That's how it works. So now, as we said, explanation, engine X is a popular command. This command will start an engine X container that listens on port 80 inside the container. But when we map port 8080, I'm making the containers web server available on my local machines port 8080. So now, let's run this. Okay. So I want to show you something. If I run this now, look, it's running from the internet. We start showing us some logs. It says it cannot find the image locally. That's because I've never pulled it. If I have pulled it, I will see it here in this place. When we say Docker images, right? I will see it here. And if I have it here, it will not pull it. And if I have it here and it's not updated, it's going to look at which layers, all the cache, like you see, it's telling you these are layers of the image. It's telling it will pull the ones that I don't have, or maybe the ones are not updated and updated for me. So right now it's pulling it from engine X. You can keep going. So once it finishes, so once this is running, is running. Now we can want to show you guys something else. So let's say so guys, it's done. It's done building, right? Downloaded newer image for engine X latest, blah 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 blah. It's done. Now that is how we also pull an image in detached mode, right? Which means run in the background. If I don't use this -d, this terminal has gone. I have to open a new terminal because it would keep whatever. Okay, I'll show you guys, I think. And this P port, so I can access my engine X on this port, 8080. Remember, we could do this from the UI, right? But as I said, terminal is the key. So now if I want to access this image now that we have just run, right? Also, if I say Docker PS, look at it. Docker PS, you see we have it. This is the container ID and it's using this image. If I say Docker images, look at it here. It's there. So now to view this, all I need to do is I'll go to localhost. I think, what did we use? We used 8080, right? 80. It's live. Welcome to Engine X. If we see this was successfully blah 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 blah. And that is it. You see how fast and easy this was. If you're using a VM now, it takes more steps. You have them again sudo apt calls at get at whatever. So that's how it works. Now we know how to do this. And if we want to stop the container, we all know how to stop the container, right? So we're going to be building our own Docker image right now. I hope we're excited. Yay! So to build our Docker image, of course, we need to have a folder, right? Because we're going to be writing code, right? So I don't know what should we name it. Let's say static website. Static website. And in this static website here, let's say we have a index.html. We have an index.html. I already have my code because me, I do not write HTML. So I copy this code and I paste it here. There's a syntax missing, I think, at the bottom. Yeah, well, /HTML was not there. Yeah. So hello from Docker, right, guys? We save this. Ha ha ha. Anyway, where was I? So we have this ready. I've saved this. We have our folder and all of that. Next up, we need to create a Docker file. So inside the same directory, we have to create a Docker file with this content. And by same directory means what? Inside the same place, right? Remember, your Docker file is always like in your root repository. If you put your Docker file in a folder in another folder, you might have to access, you might have to do /path/path. But mostly people leave it in their root directory. All I need to say is Docker file. Immediately I put, you see our doc has appeared, and I say enter. Then I paste my commands, right? So this is why I love Kusona is giving me auto complete responses, right? So I don't know why this has not been working since. So if you check, you see that it's recommending some things we should add to our code. That's why I told you guys to use Cursor. Anyway, so we said from Nginx, we want to use Alpine. This Alpine is a tag. If I come back here, if I come here, sorry, let's go back to Nginx image. You see, we can see one version 2.3 Alpine, Alpine Slim, all of that. They are just tags. They are different versions of Nginx. If I just pull Nginx alone, it means I am pulling the latest version. That's it. But if I want a specific version, maybe they say the latest one has some code problem, right? And I said, no, I'm used to using Alpine. This is Alpine here. This is the Docker file for Nginx Alpine. So instead of coming to build this yourself, Nginx has already done it for you. So now I said from this, I want you to copy this, everything in this directory. And the only thing we have in directory is what? Our index.html. Copy it to this path /HTML. And we have our Docker file ready. Now, what do we do next? So we then build the Docker image. And how to build? And how to build the Docker image, guys? What do we do? Docker. Who can tell me the next command? Anybody with photographic memory? Sorry? Hello? Who's talking?
Docker build the file name.
Just Docker build, then let's say if the file name is XXX. That's all. Something's not missing.
-t.
And what is that, goodness?
Tag. The target. Yeah.
Very much. We need to tag it. -t, the name. If the name is static website. Now, static website, then what else? Something.
Stop.
And what does this stop mean? What does this stop means? And if I
run it, you should build it in the current directory.
in the what? Issue. Sorry, Mitty, I didn't get that. I don't know if it's even my internet at this point
I
also.
should run this particular command in the current directory that we have.
Yes, you're correct, but it also means it should run this Docker file. It's the Docker file it's looking for. So it's telling Docker to build this image called static website using the Docker file in this current directory. And this will fail also. This command will fail. Oh, it goes. Tell me why.
Still because we are not in that directory that the
When
Docker
in that
file.
directory. Thank you very much. So I'm just going to copy my command. Failed. So I need to cd static website. I enter, I paste my command back, right? And then now I press build. So this is building our code though, guys. Yay, right? We've made this ourselves and it's already building it. Is this not nice? So no matter how much code you have, it can always build it for you, right? This is fun. Isn't it fun? Anyway, it's done, right? So now after it's done, if I say docker ps, is it running? Do I see it here? Ladies,
No, it's not running.
can you tell me why it's not running?
Not running it, we just built it.
It's not running because we just built it. So if we just built it, it won't run. Nobody can remember. So if should I check maybe whether it was stopped? Should I check that? Hmm? I should. Okay. Do you see it there? Is it there too? It's not.
We have not done the Docker run command. Have
Thank
we?
you very much. Goodness. After you build, you have to run. Ladies, after you build, you have to run it as a container. Now, if I say Docker images, I would see it. Look at it here. But I have not run it as a container, so there's nothing I can see, right? And how do we run? How do we run a container? Goodness, I think you're having this kind of robotic voice.
Docker run. Can you hear me?
Yeah, Docker run.
-d -p.
Mm-hmm.
The port.
Good.
The port number and then the ID, container ID.
No, we don't need the container ID.
Okay.
All you need is what you have to call the container.
The container name.
The container name. The container name, right? So now, if I say -p and I use the same port with that 8080, you guys remember we used this port earlier for the Engine X here, right? Where is it? I even find it. Here, we used it here. If I should run this, it would not work because it would tell me the port is already occupied, right? It wouldn't work. So we can even try that out now and see. And if I name this static website, what did it say? Failed for external connectivity on endpoint. Bind for 00, blah, 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 8080. Failed. Port is already allocated. Then you might think, okay, if I can't use port 8080, let me use, so you can use any number, guys. This one, this local host, you can use any number you want. So let's say I'm using 8081 and I press enter. What does this say? Yes, Mitya.
Sorry, is it because the Nginx is still running, like it's still in use? Like if we stop it, can we reuse the ports?
Yes. That's a very, very good question. And that is actually the truth. The engine X listening on port 80 and the container, engine X listens on port 80, right? It's mapped to 8080 on our own local host. That is why we couldn't use it. It's still running here. Look, if I load it, it's still running, right? And we cannot use the same thing on the same local host port. So, which is why I said if we use 8081, I just added one on my local host. You can put any number here, guys. So you please, is this one that you can't use any number? It has to be what has been exposed from the Docker file that you use here. So 8081 on my local host. If I run this, right? So instead of using local host 8080, I come and I say local host 8081. See, it's working. Now we have two Docker containers running Nginx. In the container, they're on port 80. They are two different containers, so that's why even the port 80 is not affecting anybody because they are different, they're isolated. There's no problem. But because my own system is one system, I have to ensure that whatever port I'm using is not the same. So this is running port 8081. Hello from Docker. This is running port 8080, and that's it. We get this right. Now we know how to write and build our own Docker file. So I want us now to learn how to push an image to Docker Hub ourselves. We need to learn that. So I'm just going to pull up I want to open a new window, my personal window. Gonna bring it here. Okay. So let's say we have this, right, guys? I'll show you why we need it. Now we want to we want to create a Docker Hub. We want to be able to see that our static website thing that we created now. Want to be able to see it. Let me just expand this. So the static website thing, want to also be able to see our own image, the same way we are seeing this one. We want to see them here also, right? So we can log in. We can say Docker login on our command, on our terminal. If I say Docker login, it asks me for my username first. So you need to have created like an account on your personal, on Docker Hub, because you have to now authenticate it on the CLI. But I already have an account from Docker Hub, and this is my username. I think it's Bronze Coda. I'm not even sure. And I need my password. I don't know my password. I never know my password, so I have to go and check what it is. So I just go check for my password. Okay. I'm getting my password. I come back here and I paste it. You will notice when you paste passwords, it doesn't show. I've pasted it the way it is. So don't go and be doing Control V, because you're not seeing it there. It would never show a password because it's a sensitive detail. That's how these terminals work. And if I press enter, it's authenticating me now. What did it say? Login succeeded. Right now, my Docker, so I can even, let me go to my Docker Hub for you guys. So let me say Docker Hub. Let's see, sign up. Right. I already have an account, so I'll just say sign in. So this is and then my password. So this is my own Docker Hub account. Look at it. You can say what's new, my profile, billing, blah, blah, blah. You can check so many things, system theme, Docker home, Docker admin, all those things, right? So this is how it works. Now, I don't know what's this early access they keep throwing back for us. Now, if I go to my profile, I can see all my images that have been built. All right. So the last time I pushed an image to Docker Hub was 2 years ago. Because once you're working for an organization, it's their own Docker Hub you'll be using. So there's no need for you wouldn't really be using yours, but just for practice, you should have it. So anyway, it says display one of 2 repositories. Note that all these repositories, they're all public, because I'm a free user. It wouldn't allow me to have private repositories. So now we have this there, right? If I come back here, I've logged in. It says to it says those for credentials, which we've already done. And it says tag the image for Docker Hub. To tag the image for Docker Hub, this is how to do it. So I have to say Docker tag. Remember, we've been using -t, but that -t is when we're building the image as an image name. But for Docker Hub, we need to actually tag it, because every single image should be tagged. Whether you can use latest, you can say test, you can use dev, anything you want to tag it is your wahala, right? But we need to tag it, and this is the command to do that. So once I paste this here, Docker tag, let's say my static site is what I want to do, but I can choose to change it. Let's say I can choose to do it to test DevOps. I can name it anything I want, you know. My Docker Hub username, which is what we added in my credentials, right? Which is bronze coder. And this slash my static site is what? That is the path to our folder here. So I'm just going to say inside mine is not called my static site, it's called static website. If I say enter, okay, sorry guys, that's a mistake. The tag is the image, sorry, we use, sorry, that's a mistake. All right, that's the name of our image. Which was the name of our image? I think our image was called, where is it? Static website, right? Okay. I guess I was mixing it up with how we used to do it when we were using a CI/CD pipeline. So yeah, Docker tag, blah, 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 static website. It did not even show me any. So now we've been able to tag it. You have to tag it first for Docker Hub. Then now we have to push it. So to push, I have to say Docker push, the same way we did it. Then your Docker Hub username, right? Which is, let me say, bronze coder slash the folder name, that's static website. And I press enter. This push refers to blah, 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 blah. It is pushing, it is pushing, it is pushing. See, it says mounted from Nginx. It's already telling in the log, it's already saying, okay, this is like we're using Nginx, which is what we had here, right? It's already saying that. Great. Now, ladies, what do we have? It's been pushed. Should we go to Docker Hub now? That's my personal. Okay, it's here. If I reload this, what do we have? We have it here. Look at it. It's here, right? Can we all see this? So if I want to check my tags, I can come here. Because remember, we tagged it earlier, right? It's going to always be tagged as latest, except we clarify otherwise. So now, this is it. Now, anybody else can now run this on their system. If I give Goodness this, and she runs it, it is the same thing she will see that we have here. Everything here. She can even access these files. You guys understand? So now anybody, just because it's on Docker Hub or any registry to store your images, that's why I say GitHub Actions also has one. Safe to show you guys how to do that tomorrow. I can just pull it. I can just come and say Docker pull bronze coder static website. If I come here, I can still pull this image. If I pull it here, look, it's pulling it already. But it's not pulling the one that we pushed locally. If I say Docker um, Docker images, because we can't see it in containers because we didn't run it. You see, I have the one with my username. It's different. The one with my username. That's why you see this one was Docker / welcome to Docker, because we pulled this from Docker. This is their own username, and this is the name of this thing. This is mine, and this is the name of my file. Did we get this? The name of the folder, right? So now it's working. This is different from this. And if I want to run this on a container, the same way we'll say Docker run -d -p port, I map my port, so on and so forth. That's how this works. Now we know how to do this, right, ladies? Excellent. So rounding up, there are different things. You know, you can remove a Docker image. We know how to list it. To remove a Docker image, all you need to do is Docker RMI. RMI means remove image. To remove container is just Docker RM. So if I say Docker RMI, I carry my image ID. Let's say I want to delete this static. No, I want to delete this welcome to Docker. And this is the ID. I carry it and I put it here. It's gone. It will also untag it. If I want to delete more than one, I can also add the same way we did containers. It works the same way, right? If you want to remove all your images, very dangerous thing, you can use prune also, but it's not really good to do that. And I also wanted to show people how to inspect a container. So sometimes for troubleshooting, sometimes something will be wrong in your container, something can be happening, right? So if you want to inspect it, you can just, let's say we have Docker PS now, we have this container, and if I say Docker inspect, I carry this container maybe, and to check why is it failing. You see all the things I can see. I can see every single configuration. The name of when it was created, the argument, is it still running? Look at it. It says status running. The image, the SHA of the image. SHA is like an identification. Restart policy. All these things I can see it. That's how you inspect, right? If I want to see logs also of a Docker container, I can just say Docker logs. And I can see everything, how it was built, the processes, what happened, and all of that. And to exec into a container, do you remember when I told you guys to, if the container is running and you want to see what's happening, you can even run some commands. You just say Docker exec -it. Let's say the container ID. Then you say /bin/bash, just like it is here. And if I say enter, okay. Let me see. Execute a running container. I think I'm getting this command wrong. Okay. I think I'll check this out later. Let's see. Docker exec. Also, if your commands are wrong, you know how I told you can always ask for the right things to run, right? And it told me that alias is Docker container exec, Docker exec. I don't know why it's not working though. Interesting. Okay, ladies, I'll check this out later. I'm in a hurry. Anyway, we are done with this. Can I hear a Alhamdulillah? Yay. Anything you want to say? Goodness. Yes, please go ahead.